Good morning, everybody. My name is Chris Reardon. I am the Chief Technology Officer for RavenTek. With us today, we have Doug Fiddler, our Director of Engineering, Brandon Tannehill, one of our Senior Security Solutions Architects. We have Dave Truex, who's another one of our Senior Solutions Security Architects. We have Chris Triano, who is our Senior Cyber Incident Responder on the team. So what we're going to hit today, we're going to give you a little bit about who we are, a little bit about a background and some of our beliefs around Zero Trust. We're going to jump into the demonstrations then, and we're going to give you some guidance around where we've been with these technologies, what we've integrated within the ATARC lab that we've built, and how that actually works within the architecture. Once we're through that, we'll go through each of the scenarios that were outlined by ATARC. We have a few additional scenarios that we'll go through. Towards the end, we are going to summarize our RavenVISION Zero Trust approach and how we actually are leveraging data to approach Zero Trust. Please ask all questions in chat. We'll have it up. We'll be monitoring it. And if the questions tend to go over to afterwards, we'll just go ahead and take those longer ones after the actual each scenario. So a little bit about who we are. So we are a digital transformation and cybersecurity solutions company. So we are both Alaskan native and veteran-owned small business. We like to say that we provide small company agility with big company stability. So we have about 240 employees, both CONUS and OCONUS, and we really focus on high-level engineering, expert-level integration of various technologies, as well as just technology resale and solutions architecture. A little bit about background. When we started approaching Zero Trust, what are we foundationing? What do we believe at RavenTek when we're handling Zero Trust within our customers? And one, we think, from our solution and what we're presenting today, we're moving away from those traditional perceptions about network trust, and we're ensuring everything is constantly reassessed. So from continuous verification, making sure that we're using that verification to continually monitor changes, continually look at things dynamically and look at authentications and behaviors. We're looking at microsegmentation, meaning we're looking at completely going down to a system application component process level within a system and baselining that, understanding how we segment that from all other networks, not necessarily just having to be on 5, 6, 7, 8, 9, 10 different VLANs or subnets, but actually being able to say, it doesn't matter if I have my environments across an entire network or whether it's in the cloud or whether it's on-prem. I have an environment, and that environment is what I'm controlling, and I'm putting those controls around that environment in a very micro-segmented way. We have a strong focus on identity. We're going to talk about all of our models and how we're looking at identity validation as well as verification and proofing. And the other piece of this, when we look at Zero Trust, is what many people often know, but they don't say it out loud, is it has to be adaptive, but it's also data-centric. So it's not static, it has to evolve. We have to have the ability to change things dynamically and in real time, depending on what we see in that trust factor. What is that risk score? How much do we trust something? And where do we move on from there? And the most important part about security and IT in general is IT has a function, right? It's serving end users. So it's about balancing that dynamic need for both robust security with also maintaining operational efficiency and keeping that A side of the CIA triad and maintaining availability for your users, not restricting them to the point where they can't get on and they just say, oh, the security is too much. So it's about maintaining that customer focus while at the same time going with a trust no one and ensure that they're supposed to be doing what they're doing when they're doing it. So the solution I'm about to show you has been successfully deployed in a number of federal agencies as well as DoD. I obviously didn't represent a lot of the DoD customers on here, and I didn't call out specific technologies in these customers, but to give you an idea of the scope and scale of the agencies that this has been deployed across, particularly within the identity and device area, as well as the security monitoring area. I mean, everybody from Department of Homeland Security to Department of Treasury, Justice, upwards of 2.5 million external users at Health and Human Services for one of the solutions, 125,000 and 500,000 users at Department of State. So you can see this has been deployed successfully in a number of areas, and it's continuing to roll out. Various technologies within this architecture are rolling out across the federal government. So to give you an idea of the architecture you're going to see, the majority of our lab is built in Azure, as well as we have components that are in AWS. We do not have any on-prem components of this. Some of this has a SaaS component to it, but a lot of these are built within various regional zones within Azure. And then we have all of our SaaS solution providers, such as Okta, Zscaler, et cetera, that are also out there in the environment. So we're going to be looking at Okta from an identity, iDenfy from an identity proofing. We'll talk about Experian a little bit. From a device protection, tools that we have integrated from Microsoft, we have ServiceNow, we have Axonius, Tanium, SentinelOne, and Eternity. From the application and workloads area, we have Zscaler, Guardicore, and ServiceNow. From network and branch, Guardicore, Cisco, and Gigamon. And then what we call RavenVISION, which is our reporting layer, is really Splunk and ServiceNow. And we'll talk about how we use those two together to, we'll show you how we're creating incidents, we're generating playbooks, we're actually resolving things through SOAR, we're monitoring things, and we're doing analytics to truly show the results of each one of these scenarios. Walking through the scenarios and showing, hey, it doesn't work is great, but having observability into that and being able to execute and show, hey, from a high level all the way down to my incident responder, what am I going to do with that scenario and how am I going to approach that from a zero trust framework? So with that, I'm going to go over and start talking about scenario one. And what I will do is introduce each scenario, and then one of our engineers will actually take over the screen and they'll run through the scenario for you. I'll provide color commentary throughout the entire presentation, but again, we're going to start through each scenarios. Again, we're going to hit 1 through 13, and then we'll go into a couple other ones. So this is scenario one. This is about an agency employee who is working remotely using personally owned devices that must regularly access public cloud-based agency application. So he routinely accesses the system as a standard user, but occasionally switches to administrator mode to perform systems maintenance. His physical location changes frequently with personal travel, and at times he's traveling to countries that are designated as high risk, so higher risk countries. Beyond the standard user and administrator activity, there is a specific instance in this case where he's using administrator privileges to troubleshoot an issue and has to access another system. And as he's doing that troubleshooting, he attempts to access a system that he does not have privileges to go to, and we'll show that, that privilege denial. So with that, we're going to have Dave Truax introduce this. We're going to be covering both Azure AD, Zscaler, Internet Access, and Zscaler Private Access. Our MFA provider will be Okta, and our monitoring platform is Splunk in this instance.
The user, this agency employee, we're going to use Tyrell Wellick here. He's logged into his personally owned device. In this scenario, we're going to go ahead and get him logged in to the Zscaler client connector. And logging in here shows the multi-factor authentication piece that we have set up. Okay, and he's logged into the client connector now. And as stated in the scenario, the user changes physical location due to personal travel. So we have with our Splunk dashboard of the world map here, we have it locations of where the user has logged in based on where he's been traveling. We have a location in Massachusetts, logged in North Carolina. The majority of his logins are in the Virginia, DC area. We do have one in San Antonio here, as well as Seattle or Washington. And backing out, we also have, I did some overseas travel, and from the Splunk dashboard, we see that he logged in from Japan. Now, the user, being an IIS admin, needs to troubleshoot an issue on one of his servers. So in order to do that, we're going to go ahead and log him into we're logging him in under his admin account so that he can perform the administrative functions. And again, multi-factor authentication was in place. And what this is, being the public cloud-based agency application, what we have here is the privileged remote access portal for for this scenario, our RavenVISION lab. Him being the IIS administrator, he has access to these devices. And from this, we can get him logged in to the box. And he is successfully logged in under his administrator account. During the troubleshooting, Tyrell, as the admin, needs to look at a network configuration on a different server based on this type of scenario. In order to get there, he needs access to a jump box in order to get to that next server. So unfortunately, though, he does not have access to the jump box based on least privilege. And I'll put these, as you can see, his access, he's only got 3 assets. I'll bring mine up just so you can see the difference and how you can fine tune the types of servers or assets that you can give access to different people. And with that, that concludes this scenario.
It's important to note, they're using the Zscaler portal to actually access privileged systems and actually have all of those desktops laid out. Instead of doing generic RDP or anything else, you truly aren't even we're not using a VPN. We don't have to VPN in, do anything else. We're actually leveraging the Zscaler tool and the Zscaler portal to do all of our credentialed administration, as well as accessing then through Okta any of those other applications that the agency might be using. So with that, I will go ahead and we're going to move on to scenario number 2. And in scenario number 2, this is regarding an agency employer contractor that's working from a satellite office using government furnished equipment or GFE, and he's accessing various internet sites. So the sites vary between what he's actually accessing to support his job related research, as well as his or her personal bank. So part of the policy in this is that it's limited personal use, or they're allowed to use certain things, but they're not allowed to use others. The technologies that we're going to be presenting in this, there's going to be Azure AD, obviously on the back end, Zscaler Internet Access, which is actually going to be doing all of our controls and our isolation, MFA with Okta, and then we'll show you the results again. From an observability perspective, we want to look at all this data. We want to analyze this data and use this to really inform policies and decisions that we're making across the environment to ensure that we're applying those true lowest trust principles. Dave Truax, again, is going to be our presenter for this one. So with that, Dave, I'm going to hand it right back over to you, sir.
All right. Thank you again, Chris. Part of this scenario, I'm going to show you 3 different types of access to websites. In this instance, with personal banking. I'm also going to piggyback on it with social media. So you can see both the access to a bank site along with social media, because the social media thing kind of goes into the limited personal use that the agency has for the policy for the employees. The first one I'm going to show is full access. It goes to Bank of America, and as you can see, full access, you can pretty much go anywhere. Second one, along with the full access, we picked LinkedIn, again, full access. The next one is going to be a browser isolation. We get the redirect for browser isolation. And as you notice, we have a warning banner from Zscaler saying that your browser is being redirected to be isolated. Let me bring this up and put them side by side so you can see. So as you can see with the cursor, it's different on USAA than it is on Bank of America. So with USAA, if you right click, these are the only options you have. Where Bank of America, which is a full access, if you right click, you can open a new tab, open a new window, save links, etc. Now, what this browser isolation does is it creates an air-gapped environment in front of the web content. This type of isolation can assist in stopping of zero-day vulnerabilities, ransomware, and other attacks from reaching the end user. And also with browser isolation, I have Facebook as well. And you can tell in the URL, the isolation.zscaler.com. Now, what did not happen with the Facebook page when I brought up as compared to the USAA where you had the banner, it's cached information in the browser. But if you look in the bottom right corner here, you see the Zscaler emblem. That tells you that the page is in browser isolation. And for blocked sites, we used Wells Fargo, and trying to go to that site, you get the you don't have permission. And we use TikTok for social media, and that is also blocked. To satisfy the limited personal use, except for the agency policy, within Zscaler, you can set up time intervals. However, the agency would want the intervals set up. Say they wanted during lunchtime, it was okay for the employees to surf the internet. You can set that time up as stringent as you want by days, time, whatnot. You can even go as far as identifying specific groups. So if you have your marketing team, if you need them to be able to surf the internet and have that capability throughout the day, you can have the marketing team in a specific group and not have the time interval set up with them. Also, with that time interval, you have the access control, the firewall control rules. All you would need to do is enable it and everything would be off and running. And with all that activity that we were just doing under Tyler Wellick's account on the Splunk dashboard, we have it set up to show the allowed websites, the isolated websites, as well as the blocked websites.
So, and the important part here is the correlations when you talk about behavior pattern analysis, determining which sites maybe should be blocked or shouldn't be blocked. Perhaps they see a commercial site, or you see a site that somebody's accessing more frequently, or a user's accessing that. And you can start pattern doing analysis and really doing not only insider threat detection, but also just starting to see productivity. What are people doing? What should we be restricting in our environment? Obviously, we chose TikTok. Wells Fargo was not a dig against Wells Fargo. It's just the one we chose for this particular demo. But again, it's being able to see, hey, why are people trying to hit TikTok all the time when we know it's banned? If there's a policy, an acceptable use policy out there that says, hey, you're not allowed to use TikTok, which we all know in the federal government, that is pretty much the case right now. Why are they accessing that? What are they doing? Who are those users? Can we then target them and get them some more education? Because education is paramount. Users sign these use policies. We all click on them. We do a lot of things. But being able to really restrict that and not allow them there and actually see them continually trying to get there could raise those flags and be some of those indicators that you might look for from an internal perspective. So it is important. And again, you think about what's allowed, what's not allowed. There's obviously firewall rules traditionally, other things that can go in. We're going straight to the browser and being able to isolate the browser, then prevent downloads, still allowing people to go look at help or support sites or things that might have some malicious code in it. Being able to go look at results articles on maybe GitHub that's not approved, but not being able to download anything, not being able to touch anything, completely isolating that browser from your environment and not allowing anything to touch your corporate network. And again, all of this is happening in this case with GFE. However, even if it's not GFE, everything is not using VPN. They're not connected to VPN. They're not running anything with that. They're strictly accessing the network through both Zscaler with Okta on the back end, continually monitoring that activity. In the federal government today, we obviously understand that some VPNs, especially in the DoD world, is required. However, it's not necessarily something that we would look at from not just VPN, but do you need a true network everywhere? Do you need a flat network or a corporate network, or can people use the public internet with that VPN, with these controls in place to prevent them from bringing anything onto your network and prevent you from accessing things that you shouldn't be accessing? Okay, so the next scenario we're going to jump into, and you'll see in this scenario and one of the later scenarios, we actually combine them. And the reason for that is, in this particular scenario, we have a contracted employee that's doing ongoing improvements to an agency system as part of a development team and provides administration and routine maintenance to that operating system. They perform it on the contracted employee's corporate offices using devices provided by the company. Development work is performed on a separate network, isolated from the production network, and we're going to talk about that here in a minute. It's operated both within the data center located at the agency's facilities. When appropriate, the contractor employee moves systems from development to production. So obviously he has to move and make that same change in production. And the only difference really that came up from ATARC in scenario 4 was everything in scenario 3, but both development and production systems are cloud-based. One of the technologies we're going to be discussing here is Guardicore, which is a microsegmentation tool. And it uses the concept of environments versus networks, right? So we can stick all of our applications from the development applications and then the production application components into their various environments. We can have a separate environment that's going to be reaching out to shared services, authentication, and those types of things. But only those communications are going to be allowed from that server. It's getting very granular. And having control and actually allowing your DevSecOps team to actually see the behavior of their systems, allow them to have some level of control over, hey, I'm doing development. I need to make sure that I'm now talking to a new system that I just installed. I'm going to work with security to dynamically change that policy. So instead of having to go through a boundary change request or a number of firewall rule requests or to allow a certain piece through maybe my endpoint detection system, I can now know that I can go in and dynamically adjust that policy, put in a request and have that policy adjusted for me so that I can do my development work and then move out. So again, where that system is located is not necessarily as important, right? It's the idea of trust no one, no matter where they're at. So we're validating, we're ensuring, we're making sure, and we're securing that system at the kernel level. So with this scenario, we're going to be talking through Azure AD. We do leverage Zscaler. We have Okta as our MFA again, and we have monitoring and alerting through SOAR, and we also have ServiceNow integrated into an automated workflow. We have Guardicore for the microsegmentation piece, and then we do credentialed and non-credentialed scans, and we'll talk about what the importance of having additional data in here from Tanium and endpoint detection to ensure that we actually see files that are changed, those types of things that are happening within those environments. We do have a Cisco firewall within the Azure environment, but it is sitting on a flat network. So even though these all sit on the same network, no matter where it's at, think of it as IPv6 almost, you really don't have to worry about that because Guardicore is taking care of all of your segmentation for you. So with that, I'm going to go ahead and turn this over to Brandon Tannehill, one of our senior cyber solutions engineers, and he's going to take it from here.
All right. So starting here, we have a change ticket here in ServiceNow. This is an authorization for Elliot Anderson to go ahead and perform changes on the dev IIS server, specifically this configuration file. And it has been approved here by Tyrell Wellick. And we can see that in Splunk. Splunk is tracking this ticket, making sure that it's in place and everything's ready to go. So go ahead and log in to Okta here. My code, which needs to refresh in 3, 2, there we go. Your MFA there. All right, from within Okta, we're going to go ahead and use Zscaler RDP. And you'll notice that the only options we have are jump box. So we have our development environment and our production environment. So we're going to enter the development environment first. So here we are in the development environment. We have connections ready for development IIS server and the production IIS server. However, if I try to RDP into the production IIS server, it's going to end up getting blocked by Guardicore. I'll wait for that block to pop up. But in development IIS server connects right away. Here we are in our dev system. Let's load up. So Elliot's going to go ahead and he's going to perform his changes. And for the sake of this, we're just going to do something real quick. Change. Save that. Now he's made the change. He's done his test. He's ready to move it to production. Hop into the production box, jump box. And then just as with the dev environment for the production, we can access dev and prod. But when I try to access development environment, it's going to get blocked just like it did with dev to production. There we go. Go ahead and log into the production server. It usually takes a minute to boot up. On production, we're going to go ahead and we're going to make our change. Go, exact same change. Now, keeping up with Splunk, we have to Okta track the login here, verifying that I used MFA to get in, making sure that where I logged in from. And based on my login parameters, Splunk confirms there's no risk involved in this login. On the development side, after that, we logged into the jump box. Now this is an ADM account and it's a privileged action. And it requires that I am ADM and I did MFA, which we verified up here. And from there, it's going to make sure that my account is in the appropriate ADM accounts. And so here's Splunk doing all this risk analysis, no risk yet. My connection attempt to production was blocked by Guardicore. And then my development connection, that was allowed. So dev jump box to dev IIS server isn't allowed. And here's the rule that allows it. When I log in, I need to make sure Splunk's going to also double check to make sure that I am part of the IIS admins group, which Elliot Anderson is. And then it's going to track the file modification. We specifically set certain files to be tracked at all actions against it, so we can see the actions occurring here. Now Splunk's going to analyze that action, and it's going to say, hey, is there a change request, an approved change request that deals with this server and this file? And it found the ticket we had earlier. On the production side of the house, we did the same thing. We'll log in. It's going to make sure it's privileged action, make sure we're MFA verified. It's going to once again make sure that I am part of the ADM accounts group. My connection attempt to the dev IIS server is going to be blocked by Guardicore by this policy here. And my connection to production is an allowed one. And once again, once I log into prod, when event log, Splunk is making sure that my account is part of the IIS admins group. It's going to track the same change, look at the file, and then it's going to look for a change ticket, except the change ticket was not for that server. It was for a different server. So I do not have a corresponding change ticket, and a risk event is created. From that risk event, a couple things are going to happen. First, the event is sent to SOAR in case any automated actions want to be created. And here we have that event coming in. And then in ServiceNow, There is a ticket. Unapproved change detected, Elliot Anderson on the production IIS server. So here we can see in Guardicore, the connection temp from dev jump box to the production IIS server was blocked. Here is the actual policy that we're using, which is develop or environment segmentation. We're segmenting development environment from production environment. Here's the allowed connection from development jump to development IIS. We have the blocked connection from prod jump to development IIS server, and the allowed connection from the production jump box to the production IIS server.
So essentially, the nice benefit about Guardicore is, let's just say we're standing up a new application and we're standing up a new environment. We're putting in an isolated network temporarily, and we want to understand the behavior of that system and where environment should be in, what it's actually doing. Guardicore sits at your kernel level versus the OS, where you have traditionally an OS level firewall. And what it's doing is it's analyzing that entire system behavior, not just the network communications, not just the actual connections back and forth, ports, protocols, procedures. It's also monitoring all of your DLLs that are operating. It's monitoring your CPU performance, your memory performance. It's creating a model for how that system should operate normally. So you put that in a monitor state where you're strictly monitoring the activity and the behavior of that system for a period of time. Once you have that, you can then dynamically create those policies. So those policies then are recommended. We want to restrict 443, we want to restrict 80, whatever it might be. If it's a SQL server, we're restricting a number of things and putting controls in place on the SQL server. It's monitoring all of the users that typically access that system. So you can have pattern analysis with those users that are accessing it. Let's say I somehow got some sort of piece of malware, and that malware somehow got in there. What it's going to do is it's going to stop that from even running a process. So I know all the processes that run on my system. I understand every single component that spins up and spins down and what the normal pattern is. Any divergence from that pattern gets completely blocked. So it prevents it from traversing out, it prevents it from running or executing altogether. And then it can create an alert, isolate that, and then send it off into a honeypot to actually start monitoring if it's a threat actor coming in or something else happening. It's actually able to monitor that activity from those users. So it's a very powerful tool. There's not many microsegmentation tools in the environment. Guardicore is operated within the Akamai scope, under the Akamai umbrella, along with a number of other solutions. So we're going to move on to scenario number 5. And this is about a public user that accesses an agency's or citizen-facing system that houses sensitive PII information. The user has to be verified. So we're going to talk through identity proofing and what that looks like in order for them to gain access. And sometimes he enters data, but occasionally he's in there checking his status of what it's doing. The key here is we're looking at both Okta and iDenfy, which are going to be our authentication or our identity proofing solution being iDenfy. We've also worked with Experian in the same context. For the first part of this demonstration, Mr. Triano is a cyber incident responder, is going to show you a video of what it takes to actually do that verification. With identity proofing, to do it in a live demo, it takes about an hour, especially doing the facial recognition, doing some of the government document validation. So we'll show you the demo of that. We'll show you the fact that he was able to successfully do it. And well, it's basically what it's doing is it's coming in, I'm logging in. I'd say I got an account that was approved. I've got a picture on my employee profile. Now I want to go set up that user's account, and I want to do it in an automated way, automated provisioning. So I say that this person is allowed to go ahead and access that system, but he needs to create his own profile. So he's going to get an invite from Okta. Okta is going to send him out to that identity proofing. Once that identity proofing comes back, it'll generate all of his credentials and give him the appropriate access that was assigned to him. So with this, I'm going to turn this one over to Chris Triano. And Chris, go ahead and take it away.
All right. So this is going to be, I'll show you 2 pieces here. I'll show you our console, and then this is the video pretty much using the information needed for setting up an account. So it lets you select, what country you're using your document from, and then also lets you choose your piece of identification. This will show you the correct ways pretty much of just setting up the account, how you have to have lighting. So the biorecognition works probably the best. Also, clarity in your pictures have to be used as well for all that information to be taken. So this is our test subject, Robert, using his identification card. Once you finish taking your identification card, it will also ask for a facial picture used for biorecognition. They use this together to help verify that that is your actual document. I'll show you in the console some failed attempts. Once that's done, this information is sent off to iDenfy. iDenfy will probably take, I've seen up to an hour for them to verify credentials, but as quickly as 15 minutes as well. So then from there, let me show you the console. So our console has a couple different examples in it. First, I'm going to show you a couple failed examples. This one saw a face mismatch. So as you can see here, the identification card does not match the face. So this was denied. This one picked up on the document they tried to use and considered it a fake document. So using their database, they were able to determine that that user was not using a valid document. And then there's also an honest mistake one. Here they used the document that was expired. And then I will show you, this is me using mine facial recognition in order to pass through. And like I said, it took up to about an hour, but my information was sent off to iDenfy and then came back. And with that, we're actually able to use other features as well. Right now, we only have about 5-6 features implemented in here, but there are a lot of other features able to be used to verify whoever is trying to log into your system. So, and then this could be placed in front of any systems you want just through an API key, and then it could get off and running. And that's it.
Great, thanks, Chris. And when you think about true identity proofing, I've only seen this in a few federal agencies so far, but when you think about privileged access management or creating privileged accounts or privileged revalidation, I know even myself in the DoD with administrative accounts, we have to do face-to-face verification, usually quarterly, sometimes biannually. There's others that do it monthly. And that's where, either the sponsor, the agency sponsor, whomever that may be, has to get on, do face-to-face, validate everything that they need access to. With something like this, you can put conditions in there that list each one of those user systems, and they have to check every system that they're supposed to have access to. They need to then go in and do an identity verification. So instead of now having 10, 20 meetings for all the people that you sponsor for administrative accounts, you could do identity proofing for that admin revalidation. You could set that revalidation to be automatic at certain points or certain intervals within the life cycle of that user profile. So again, it's just something that's very powerful. It could reduce time from a meeting perspective, but it also enables people to automatically go in, not have to set up a meeting with their sponsor, not have to go through a lot of things, and still have that same level of trust and validation that that is the user that's validating that he needs an admin account. He's validating that he needs access to whichever systems are currently within his profile from privileged access perspective. And then the system is going back in and making sure of that. You could go to as far as automating if they uncheck a system, say, I no longer need access to IIS because now I'm a database admin. It can actually remove your IIS privilege within your profile. So those are the things that you can do with both iDenfy and Experian-like tools, and identity proofing is starting to become more and more common, especially for those public-facing applications. How do I ensure that I'm the person logging into Medicare? If you ever go in and get your If you're ever going in to get your credit report, it's doing the same thing. It's actually pulling your credit profile and asking you questions about where you are, what you're doing. We're now adding that government document piece, that facial recognition, that biometric component to it that allows us to scan that. Even with the CAC cards, everybody knows that their fingerprints are on CAC or PIV cards. Those are stored within that system. Being able to tie this into a system like that, where you actually then have to use your fingerprint reader. Those are the types of things that you're able to accomplish with this type of tool and this type of solution. So with that, I will go ahead and we're going to go into the next few scenarios. So this is very similar to what we talked about in scenario 3 and 4. So in scenario 6 through 10, the biggest difference between the activities that are occurring is where the systems are located, where these API calls are coming from, and that external connection. So again, in our case, we're using Guardicore as the microsegmentation provider, and it is able to, again, track that environment, ensure that nothing is touching it. Doesn't matter where the system is or what it's doing, it's communicating directly from that system, and all of its controls are right on that system, preventing any access. So in this particular scenario, we're talking about an agency system that interfaces with another system. As an example, it was accessing fingerprint information as part of a background investigation. So think of it as iDenfy actually accessing the fingerprint information so that they can validate the user. Both systems, again, in this case, it starts with public cloud-based and then it moves to where they're at. For us, we are network agnostic and landing zone / location agnostic. It describes the normal operation of what's actually occurring between that connection. And then it's talking about what happens when an incident occurs and we're informed that that agency system is experiencing active exploit. It's under current threat. Within this, you're going to see a number of technologies that we've included, and we'll talk about those a little bit, but we're really going to focus on the automation piece and the detection piece. So we're going to talk about Azure AD, obviously, and Zscaler as part of the front end, communicating back and forth for security purposes, Splunk and Splunk SOAR, as well as ServiceNow doing the incident management and the security orchestration automation. And then we have Okta for MFA from an APM perspective. So users accessing it, we want to make sure that, hey, users can still access this. We want to see based on that threat or based on that vulnerability, what is occurring for those users? Where is that at? We want to constantly monitor that user experience to make sure that that exploit isn't affecting more than just the system that we're looking at. From there, we have, the compliance baselines for, are we going to find an indicator of compromise? Where is that at from both Tanium and Splunk feeding data? On the network side, we're feeding data from Cisco devices, Microsoft Defender, Guardicore. We're going to turn this one over to Chris Toriano. Chris Toriano is going to present this scenario and we'll go from there.
Okay, so this scenario, first one I'll talk about goes through 6 through 9, and then 10 is like a sub scenario to these as well. They're built in, it just has a little bit different of a configuration. From an IR standpoint, I've seen a lot of third-party breaches. Their notifications come through email, but this can be started earlier in the process. I'm just going to take it all the way back to our email breach detection. So this is an email sent in, and I'm sending this over to our service desk. Our service desk will then come back to us with a ticket being created. This is the ticket that has been created with all the information in it, including the originating URL and the IOCs that has been detected through this URL. And then also Splunk will also pick up on it, and it will pick up this ticket. So this is as close to real time as we wanted to do it, just because we wanted to make sure that everything was running so we could have everything to show you guys. But we started this around 11:17 and it ran through the whole process. So this was being created, and off of its indicators, it was sent to our SOAR playbook. Our SOAR playbook has a condition set, and then it will block the DNS. For these particular exploits, it says that they are currently being exploited, so we want to sever that connection immediately. So the first step is the Guardicore DNS block. After that, then we use a search action. This search action takes place in Guardicore and in Splunk. It will look for any of those IOCs or those URL, any indicators of compromise found, and it will grab that data. And then our last portion of it will send it to Splunk, which will disperse it throughout where it needs to be. In this case, it goes to ES for our incident responders. So in here, we ran this, as you can see, was ran 38 minutes ago. The first portion was the block DNS, which was sent to Guardicore. Shows here that it was a successful block. Down here, we have our search IOC piece. This search IOC piece came back with some information. A little bit harder to read here, but if you look down into it, it shows all the way down to its directory that it's in, the size of the file, when it saw it, and other information as well. And then down here is where it posted back into Splunk, where Splunk took this information through our dashboard, made it a little bit more pretty to look at, something for our incident responder to look at as well. If they aren't in there, this was also created as a notable event in our ES dashboard. As you can see here, this notable event was created, showing the URL, any information needed with it, assigns it to an incident responder. This one came to me. Sets the status to in progress, gives it an urgency, and it starts its process off. Now, the scenario 10 is a little bit different because it seemed like we didn't exactly want to sever the connection between that. So for this one, it's a similar playbook. The condition's a little bit different, set off of a search IOC rather than a breach. And this one just searches for the IOC, skipping the sever connection piece through the DNS records, and then also posting that data, which will also give us another notable event.
So in this scenario, we're talking about remote users of an agency's cloud-based high-value asset system are having connectivity issues and constantly kicking them off their session. Outline tools you would provide the administrator for troubleshooting. So this is more of an exercise in, hey, let's talk about how we would monitor these systems. So, I mean, there's so many things when, hey, I'm constantly getting kicked off the network. You're going to engage your network team. You're going to engage your help desk team. They're going to call the help desk. They're going to put in a ticket. They're saying, I can't get on. Well, how do you know what that is? So in this case, we want to combine a lot of data to determine what's happening. Is it the zero trust ZTNA solution? Is it some issue with a legacy firewall or VPN? Is there an issue with their account, or is there an issue with their system? Perhaps they're compromised. So we have to have all of that data and understand it. But typically where we start is within an Eternity platform and within the Splunk platform. So I'm going to actually show you a few things in this scenario beyond what this scenario is particularly talking about. For me, I'm going to log in just as myself. And one of the things that we hadn't showed up to this point, and some people may have noticed, is a token-based or a FIDO-based authentication. And for my account, I don't use a password. So what I'm using here is I have a biometric key, which actually leverages FaceTime on my machine, or facial ID on my machine, as well as my token. So when I click on this token, it's going to trigger that token. My camera pops up on my system, and then I simply touch that YubiKey, and now I am in, and it's going to ask me for it's going to step me up when I go into my next solution. So again, I've got two factors directly for something I have, something I am, and I did not use my password. So for us, from an Eternity perspective, Eternity is an end user experience monitoring tool. So it's actually built to monitor the experience of the end user from the end user perspective. So I'm going to bring this over here. Essentially, what we're looking at is we're going to open up a product tour, and we're going to run this on demo data. And if I want to monitor my end users, I want to monitor anything in that environment. I want to monitor a specific location. Maybe it's Outlook, maybe it's something else. All I really need to do is go look at my remote users. So I actually want to see what's happening with my remote workforce. And I get a lot of data. So now I'm going to come up, I'm going to get a summary of where they're working from, what they're doing, what their usage is. I have SLAs set up so that I know, hey, this is when I'm in the office, it looks like my IMS app is not working as functionally as when I'm not in the office, or as when I'm remote. So it's interesting, that's probably tied to that location. Perhaps there's an issue with the network there. We can see all the health events across those user systems, but I really want to drill down to an individual user. So what I'm going to do is I'm going to go in and I'm going to look at the actual health events that are occurring across the environment. What is actually happening on individual systems machines? So now I can go down here, I can find whichever user that might be, and let's just say it's Lewis. So now I have Lewis Pinder is his name. So for me, I want to see what's going on with Lewis. And here I can look at his workstation as well as I can look at him as an individual. So now I'm actually looking at his user experience. I'm analyzing this data. I'm seeing what his connectivity was looking like. I'm looking at the resources that are on his system to determine, hey, why was he kicked off the network? And this is just one example of where we pull it in, but how do we actually bring that together? How do we see that from an enterprise level view? So some of the data that we don't have built into Eternity, but we did build a custom API for the Riverbed Eternity solution so that we can start aggregating this data beyond the concept of, hey, I'm just going to go into each individual tool. I need to have an Eternity expert. I need to have this guy. No, I need to look at not just the end user data. Maybe it is something on the network. Maybe it's the Wi-Fi that's out there. Maybe it's the link coming into the data center. I need to monitor that entire environment through and through. And what we've done is we've incorporated that into what we have from a RavenVISION perspective, where we're pulling visibility integration from security infrastructure, operations, and network data and loading that all into a centralized dashboard. So again, and you'll hear this in the next probably 2 presentations, but from here, I can look at my network. I can go in to see what's going on at individual sites. I can look at my routing overviews to ensure that things are operating properly. This is all event-generated demonstration data, but I'm able to actually go through and see what's happening in my environment. I'm able to see what IPs are having issues, what routing protocols, is there anything flapping at that site, et cetera. And pulling all of that together, then if I want to tie in my end user experience, this is just an example of some of the data we're pulling from that Eternity tool, again, all into the Splunk environment to provide that single context view of your environment. Zero Trust is about a lot of data, but that data then applies to not only the security of your environment, but also, again, that availability, that efficiency, the operational sustainment of your environment as well. So here I can see the application use trends. I can see business activities, so open mail, closed mail, how long those are taking, how long it takes to launch Outlook, how long it takes to log into a system. I can see response time by various device types. I can look at the longest boot components, things that might be taking long. Those types of things that you're able to really drill down, and not only, from a use case that's built around just the network. Hey, I'm getting kicked off. Of course, everybody's calling the network. Why do I keep getting kicked off? There's so many other factors that go into that to truly get to a root cause analysis. You have to have the data from every tool that is monitoring that system, and starting here and working your way in allows that help desk or those users to really start drilling in and seeing it themselves. With some of these tools, especially with Eternity, you actually do automated remediation. So you're actually able to go out and remediate then if there is a particular issue, maybe it's a process crash or a system crash. Recently in the federal government, or the past month or 2, I've seen a net system DLL that's been occurring in a Windows 11 update. That's happening across multiple customers. Things like that, where in the cloud version of Eternity, I can actually come in here and I can drill down digital experience, and I can look at what their digital experience index is. So I can actually see, okay, hey, here's my productivity tool use, here's my business applications, here's the performance, here's my performance on poorer applications, drilling all the way down in. And then if I really want to industry benchmark my overall user experience versus the rest of industry, using that aggregated data set, I can go in and run that benchmark analysis. So perhaps I want to benchmark this against the federal government. I want to see how I'm performing from a device perspective, from applications, from productivity and collaboration tools compared to all others. So again, it gives you kind of that weighted score, and then it drills down into each component and how it's actually comparing it to your peers. So from a scenario 11 perspective, it goes a little bit deeper than just, hey, this guy can't get in. It's how do I use every single tool that I have at my disposal, and then how can I remediate that? So talking about setting up an ML toolkit to detect things like this guy getting logged off or kicked off, making that an anomaly, making that detected based on the amount of users that are there, actually doing an analysis and a correlation that says there are this many users at this site. And when that spikes up, I can now go in and I can see that that trend or that pattern is behaving badly. In this case, you would want to look at something under the same guise, but perhaps it's not the user, perhaps it's the service that they're asking, right? So I want to look at, their database and understand what's happening there. So now I can go in, I can not only look at the database, I can see there's an issue with that database. Perhaps he's not getting kicked off. He just can't call the SQL server because it's spiking CPU. Why is that server spiking CPU? Well, someone changed that system password. That system password is no longer allowed to make those calls, drawing all those correlations. So when we talk about zero trust today, and this is obviously the ATARC Zero Trust Lab, the data that's involved in zero trust is universal for security and operations. So whether I'm analyzing a behavior of a system, I'm looking at CPU spikes, that could be an indicator of compromise. It could be an indicator of other things, just operational perspective. If once those teams start working together with that same data out of that same context, they organically start to predict things and see patterns and analysis that they're able to troubleshoot. So now we can create playbooks. We can remediate. Hey, we know if there's this many users, we need to recommend they hit this other system, or they need to enter through this other way. The benefit of using things like Zscaler and other components is Zscaler then can come in and tell us, hey, here's the path that user's connecting with. Looks like the network's fine. Now I need to go back and look at something else and determine what's wrong with the system itself. Is it that net service? Is it the Wi-Fi they're connected to? Whatever it might be within that environment. So very similar concept. So now we're talking about really, these next couple scenarios are all about the data. So scenario 12 is about a ICAM administrator that's reported user credentials that were compromised and describe the tools and methods we would use to validate that unauthorized access to the system under the ZTA umbrella that they haven't occurred either on-premise or cloud-based. So with our tools and the data that we have, we have Splunk ES running threat analysis. We have Guardicore out there analyzing users that are coming in. We have Tanium detecting users, and it can actually predict lateral movement. SentinelOne doing that credential protection, so we can push this back out to the SentinelOne platform. The SentinelOne platform can automatically jump into directory and disable that system. We're looking at all of the network traffic on the environment. Do I see that user in NetFlow? Do I see that user doing something within mail or other areas? So we're looking at span traffic. The Cisco traffic coming in, obviously, then we have Splunk doing some monitoring, Guardicore monitoring network connections. From an identity perspective, we've incorporated, iDenfy, Active Directory, Okta. Perhaps that user gets shut down. And when I show you some of the dashboards of how we're looking at this, what we're doing prediction-wise and trending out, maybe when that user comes back in and resets their password, we want to trigger that to go to an identity proofing solution. If I need to reset my password, do I need to run them through identity proofing because it looks like they logged in from a place that it wasn't supposed to be logging in from, even after they reset their password? Is there some sort of insider threat? Maybe it's not the credential that's compromised. Maybe it's an insider threat, even though that's what you were told. So from here, again, under that same concept, that same umbrella of a single pane, I want to look at my user activity. I want to look at access enforcement for that user. I can drill this search down and actually see, successful privilege logs and remote logins, where everybody's coming from. I can look at trends and behaviors of that user, and then I can also come down and look at each individual user and where they're coming in from. So if I want to drill into a specific username, obviously these are randomized. I can actually see what this user is doing and where they're coming from and how they're behaving on my network. But really the important part is, hey, I've got a user that's credential was compromised. I want to make sure that there's no outlier activity occurring within those logins. So how do I detect outliers? Well, I have my underscored outliers, my overscore outliers using Splunk ML Toolkit, pulling all of my authentication data and all of my access data. I'm now able to see my user login outliers. So users that don't often log into a system, or users that are logging into more systems than they normally would log into, all of a sudden start popping up and they start displaying issues, right? So now I can go into each one of these outliers, dig further down into this source and make sure it's not compromised. If we know it's compromised already, we're already going to send this to ServiceNow. ServiceNow is going to have an incident ticket. That incident ticket's going to go to either Splunk Core or directly to the ICAM solution provider, meaning Okta, and that would automatically shut it down. So that's the workflow and the process that we would follow for an identity breach And again, it's getting that user back online. So if they have an issue with credentials or they've been validated, that's great, but now they can't work. As soon as we lock them out and disable them, they can't work. There's other scenarios where when we talk about user credentialing and users logging in, where we want to think about things like, where are they allowed to work? If we go back to the scenario 2 a little bit earlier, where we were talking about the user worked in some high-risk locations, one thing we failed to show on that, and I can go back and show you, is that user was only allowed to log in with his regular user for that particular scenario. So having credential issues or restricting the types of credentials and the conditions of that behavior is paramount. So let me go into our ATARC lab app. I'm going to pull that one back up. And again, you can see here, Tyler Wellick's logging in. And in this case, we did use Japan as the spot. But again, we can see that, hey, it's just his Tyler Wellick account. It is not his admin account. Over here, we can see it was his admin account. We can see his admin account twice, and then we can see his regular account as well. So we can tell that, hey, yeah, now I'm not allowed to log in with my admin account when I'm in a high-risk situation or a high-risk country. Obviously, for the purpose of this demo, we didn't deploy something out in a high-risk country. We didn't want that out there today. So that's what we came up with. All right. So we're going to hop on to scenario 13. So this one's interesting. This scenario in particular is an agency has decided to perform penetration testing against their HVA systems operating under the ZTA umbrella, both on-premise and cloud-based. Describe the tools and methods you would provide to accommodate these penetration tests. So it doesn't necessarily say which team we're on, but in this case, it's all about data. One, prepare for a penetration test is preparing for normal operations. In the federal government today, in my mind, there's a penetration test every day. It's just real life, right? It's an actual threat that's coming in. To actually prepare for a penetration test, when we start going down the cyber kill chain, we look at what they're going to be doing. What data are we going to use to actually detect, the reconnaissance? What data are we going to use to detect an intrusion and an exploitation? Well, all the way down to, what they're really doing and what their intent might be. Are they exfiltrating data? Where are they getting that data? But obviously, we don't want them coming in at all. So we want to pull all of this data. We're going to start looking at, depending on whether you're internal or external penetration testers, I'm going to start analyzing a lot more user data. I'm going to start looking into reports of spam mail coming in, all the things that I would normally do as a cyber incident responder or cybersecurity specialist. I'm going to be looking at that data. In order to pull that data in, I'm using Splunk Enterprise Security. I can leverage ITSI to monitor the performance of systems to see if there's any anomalies on those. I can track the inventory of my systems across the environment to make sure something rogue is not being added to my network. Zscaler obviously is going to come into play, make sure that our users are actually using the appropriate ways to get in. Tanium doing all of my threat protection or my EDR and my software distribution, et cetera. Guardicore doing all the microsegmentation. Those users, from a Guardicore perspective, last penetration test it hit 99 versus another tool that hit like 56 exploits. And that 99th one was stopped even though it came in. So, I mean, those are the types of things and the types of tools that we're going to use to not only prepare for it, but then when you want to see it, let's say something happened, something came in, how do we find out what happened? That's where pulling all of this data together and actually running things like a investigative analysis across all of my tool sets. And again, this is demonstration data, but I want to look at my network traffic. I want to monitor that. I want to monitor all my antivirus tracking. I want to monitor my IDS activity. I want to monitor my host event logs. Let's say I've identified that, now I know a host that looks like they're targeting. Maybe I have an idea or a clue and I need to prevent that from coming in. Well, what host was that? Okay, well, it was Acme 5, 4, whatever. Now I see that, hey, network traffic looks like it was starting to spike up here. It's kind of wavy up and down. I've got IDS activity actually happening. I got a lot of policy violations. And looks like I got reconnaissance occurring on my network. I also have a number of failures actually coming into my environment. So what really happened? Nothing really showing up on antivirus. So I come down here, I can see my users that are coming in and out. I can see whether they're allowed or whether they're not allowed or why they're allowed and not allowed. You can see this guy here is all of a sudden coming in from, so K Jackson's starting to come in from multiple source IPs. Why is that? Why are they coming in from source IPs that aren't supposed to be? Once I get down into my IDS activity and I can see this, look at this, I got bad traffic detected. I've got host sweeps going on. I've got instant messenger access occurring across my environment. I have policy violations left and right. And the further I get down into seeing what's happening, I'm now getting mail relay attempts that are being violated. I'm getting SMTP services that are hitting. So obviously I have something going on in my network. I really need to figure out where that came from. As I go down, now I'm getting IAM-based file transfers. So these file transfers are coming in. We've determined where it came from. We know what host it's on. That host is then locked down from a Guardicore perspective. We're pushing that back out and we're preventing that from going any further. But being able to monitor during a pen test and see things that are anomalous and happening in here, and even building anomaly analysis with the ML toolkit into this environment is paramount to actually being successful in managing the entire kill chain during a penetration test. If we want to make sure we're ready and we want to make sure we have all of our controls in place, and I want to see, hey, what defense techniques do I have, or what am I ingesting from a data perspective? Well, now I know from a network traffic analysis, I don't have enough data in here to truly troubleshoot and worry about, client server payload profiling. So with this, we're actually taking all of the data in here. We're looking at the MITRE defend coverage, and we're seeing what's happening out in the environment to make sure that if we don't have the logs, we can go back out and see if we can get those logs and get that data to actually defend against that incident. At the same time as the incident's happening, or things that were occurring on our network, bringing in the MITRE attack function, the things that are actually being seen across the network. So actually all of the MITRE attack techniques that are actually being discovered based on the logs and the things that are coming in throughout that environment. So that is scenario 13. And that concludes the first 13 scenarios that were brought in by the ATARC Council. We do have one more scenario we wanted to show you from a Zscaler perspective, particularly related to an agency engineer that's utilizing Wireshark frequently in his daily tasks. And he notices that the agency approved applications is a few versions behind. So he's like, all right, well, compared to the Wireshark website and what it's currently advertising, I need to get that. So instead of going through the normal IT process and IT security and validating that file, he tries to cut corners and go download the site himself to save time. When he attempts this, he receives a warning banner that it's failed to download the update. So he contacted security, let them know to follow the normal procedures that were in place. But then he tries to go home. And when he's at home off net, he's now trying to attempt to download a different file, which is a PDF, and he receives the same warning banner on the failed attempt. So this particular scenario is, obviously leveraging Azure AD, Zscaler, ZIA, and ZPA, particularly ZIA, and the DLP function, and then monitoring all of that activity within the Splunk environment. So I'm going to give it over to Dave Truex.
Okay, with this scenario, again, for the demo purposes, I'm using Tyler Wellick. He, from scenario 1 and 2, still have him logged into the Zscaler client connector. Noting, again, like Chris said, notices that the Wireshark that he uses is out of date. So he takes it upon himself to try and download it himself, the latest version, and sees that the executable is blocked. And with the PDF, he tries to download the PDF and again gets blocked as well. Keep in mind that with, just like I had said in scenario 2, you can set up the different file extensions to be blocked. Some examples that can be blocked from downloading include exe, PDF, zip, MSIs, DLLs, ISOs, cab files, just to name a few. So with that, you can also set it up to, good example would be your patch team. You would only want them to be able to go out and to Microsoft site, or for the DoD, go out to the DISA site to download the monthly patches, the MSIs, the EXEs for the Microsoft products. You can actually fine tune the access policy to where it's just that group that can download those types of file extensions, and nobody else. And you can even go one step further and, based on network bandwidth, you could put a window of the patch team can download these types of file extensions only between the hours of 6 p.m. and 8 p.m. on patch Tuesdays. So you can really dig down in the weeds of how you want to set up those types of access policies.
So that concludes our scenarios. However, as part of the ATARC recommendations, they looked at, other scenarios or other things that we could discuss to help educate. And really, it's about what we call, it's the importance of observability for zero trust. And it's leveraging data to drive outcomes, not just from a zero trust perspective, but again, from that operational perspective as well. So when we look at, geographic differences in systems, detecting where those users are logging in, what they're allowed to do, where they're actually, location specific or approved travel type of scenarios, if I'm working in Bangladesh next week and I put a ticket into ServiceNow, we're automating that workflow to go from ServiceNow to your zero trust network access solution to say, hey, yeah, you are allowed to work there. It's going to give you that lower risk profile. Whereas the same time I'm logging into Virginia, I know somebody got a hold of my credentials or violated that, and I get an insider threat sitting at the office acting as that behavior. Whereas normally I'm going to get shut down in Bangladesh because there was nothing in the system that alerted the SOC to say, hey, don't shut down that user. A lot of that is already automated. So now we just add that additional condition in there to say, hey, go check this, go check the actual authorization. What would normally be a personnel process or a personnel security process can then be incorporated into that trust or that risk algorithm. When we talk about moving workloads, analyzing workloads, monitoring on-prem, cloud, continuous monitoring, evaluation, all of this relates back to, again, that data. All data is security related, but it's all data is important for everything else. We talk about critical infrastructure, monitoring IoT, from a Guardicore perspective, and we'll address this later, but being able to monitor more than just Windows and being able to actually isolate, maybe you have an ICN or industrial control network that you need to isolate, being able to isolate all the way down to those legacy OSs, all the way down to those individual components that are running systems that normally would be completely air-gapped, but can we then enable people to be more productive by making them less air-gapped? And how can we do that to ensure that it stays secure? There's a lot of other tools and a lot of push around IoT security now. And from a zero trust perspective, it's, trust no one. Unfortunately, even with all the policies that are across the federal government, what we see a lot is, USB sticks. I'm going to take a USB stick. I'm going to stick that USB stick in my computer. I'm going to pull down my build profile. I'm going to go put that in my CNC or whatever it might be, and I'm going to run that process through. Well, how can we secure that more efficiently and make sure that those USB drives highly vulnerable, especially if you don't have the right ones or you're not using the right process. And given that it's off the network, how are we monitoring to make sure? Want to make sure that system doesn't overheat or we lose production capability or we can't make an aircraft part or a tank part, one of those types of things. That's the real paramount of getting around IoT security. And then cloud-to-cloud integration and public and non-employee facing customer services. Cloud-to-cloud integration, especially when you talk about the concept of less physical perimeters, right? Less that physically defined perimeter, more that software defined perimeter. The more you get software defined in both your networking and your security stack, especially from a micro-segmentation perspective, the better you're going to be able to be mobile between multi-cloud deployments. And then the governance around that, about how do we actually take that governance for that multi-cloud deployment and apply that in real life. So from our perspective, bringing all of that data in, taking it from that executive level, being able to see the operations of your environment, understand your landing zones, understanding what your costs are. Oh. And then coming into my, AWS, Azure, GCP, actually looking at utilities, your utility rates that are happening. If you have a colo site, let's say at an Equinix or whatever it might be, being able to incorporate that in, incorporating your hourly wages and your soft costs into support, as well as the overall software support, taking into account things like, hey, how well do I know how far this is deployed across my environment? How well am I using tools? Going in and looking at things like individual resource costs, actually looking at an endpoint cost. And let's just say Tanium, for example, your organization buys Tanium, 5,000 seats of it at $52 a license. Well, why does this say $104? Well, it says $104 down here for that Tanium agent on that particular asset because I've only deployed 2,500 of those. So when we look at, from a CIS perspective, you're looking at accurate inventory. How do I measure 2131? How do I achieve that? How do I make sure that my confidence in everything that I'm getting logs from and that I'm reporting on are there? I mean, that they're truly my assets that are of record. I have ServiceNow going out and doing discovery, managing my CMDB for my hardware and software asset management. But I've got other tools out there. I've got Tanium, I've got Eternity, I've got Trellix, I've got McAfee. You name the tool that exists in the federal government, you probably have it. So from there, you can look at tools such as Axonius, which is actually pulling from all those sources, looking at all of that data, doing cyber incident analysis, and actually determining, I'm going to pull that up here for you, determining what systems you have deployed, what systems aren't deployed, the difference between those systems, different software versions, etc. As soon as I put it up here. Sorry for the dead air. So from an Axonius perspective, now I've got sources coming in from all locations, and I can actually go in and look at all of the tools that I have out there, all of the sources that I'm pulling in from. So for this one, I'm pulling from AWS, I'm pulling from Eternity, I'm pulling from Guardicore, I'm pulling from Azure, SentinelOne, ServiceNow, Splunk, Tanium, all of the Tanium products. And I'm actually able to see, hey, I've got 190 devices in ServiceNow, but I've only got 108 deployed with Tanium Discover. Well, what happened to the other 88 devices that are out there? How can I actually go back and do a rationalization of what is actually out there? What am I using? And why am I not deployed the way it should be? I can look at my software inventory, again, pulling from all of those sources and then easily correlating that data back and forth. Same concept as before, instead of pulling all of this just from this Axonius tool, pulling that data back into Splunk, being able to go into Splunk and actually pull that data from an Axonius perspective, leveraging the TAs that are out there to actually ingest data from all of these tools and do that analysis. Go back here. So where does that all come from? At the end of the day, a lot of this, again, is about data centric. And what we focus on at RavenTek is RavenVISION, which is visibility integration for security, infrastructure, operations, and network. And it's about providing that single context observability platform to really allow you to start drilling into what you need to automate, what analytics you need to look for, and then get that zero trust visibility, and also provide that high level governance. What can you see? How can we manage this, et cetera? And some of those sources that we've talked about today that are built into this lab as we speak, we're looking at your security incident monitoring, we're looking at continuous authorization and monitoring, your AI and ML behavioral data, your threat intelligence feeds, your identity and access management, your IT service management, your asset management, network performance and application performance, which commonly a lot of the vendors out there call observability, a combination of APM and NPM. But if you're missing the security part, you're missing too much. You're not able to tell, hey, when does my operational change affect my security posture? When does my security posture increase affect my operational conditions? So when we look at zero trust security being about devices, applications, network users, all of that data analyzed and then put into an automated playbook like we saw today, visibility into each of those is super important. but comprehensive observability across all of that data is what really is going to enable you to drive effective zero trust policy decisions. And as part of ATARC, Jerry Karen had another version of this that he developed a while ago, and we took it and we created our RavenVISION data intelligence model. So when we work with customers from a zero trust perspective, well, we presented a lot of products today. We know that zero trust is about a lot of what you already own. And you may already own some of the products that we talked about here on this call. And it's about integrating that into an overall observability picture focused on zero trust. So looking at your device and endpoint data, your network and environment, your application and workload and user, and breaking down those operational silos, those not SOC silos for the various teams, and bring that into one data environment. We're doing all the automated tagging, we're doing all the masking and segmentation. We have data rights management in there, all of our encryption, our metadata management, classification, DLP, fusing that with the intelligence, both internal and external threat intelligence feeds, your CrowdStrikes of the world, et cetera, as well as any OSINT feeds that are coming in or proprietary feeds. Now, once we have that, we can rope in that visibility and analytics. It doesn't necessarily have to be in one environment, doesn't have to be in two environments. We can feed that via API back and forth between the tools to start figuring out what we need to do, right? Start doing machine learning, discovering and baselining systems. I think one of the most critical components of a true zero trust model is understanding the baseline, understanding what is normal. What is a normal piece of behavior so that when I see something that's abnormal, I automatically untrust that behavior. And once I untrust that behavior, I no longer have to worry about what is happening. I just go in and resolve and see what that and investigate that incident. So as you're doing this and as you're pulling all this data, you're going to start seeing common patterns and common trends that are happening in your environment. So what do we want to do? We want to take those common patterns and trends and we want to automate those. You can't boil the ocean with any policy. Zero trust is a framework. It's meant to be done iteratively. A lot of the federal government has already started with even some of the products that we talked about today, as well as an overall strategy. There's models out there from CISA and DoD that give you kind of a reference. Our goal is really to actually come in and look at not just your zero trust maturity, but also your operational maturity. How can we use that data now that we're getting because we're focused on zero trust to start responding to incidents on both sides, start working with the DevSecOps team and shift that paradigm to being more security first without security becoming a barrier. Security sometimes gets that bad name, and what we really want to do is shift that paradigm to say, hey, I like my security tools because it allows me to do what I need to do when I need to do it. And sometimes, yeah, I need to escalate privilege, or I need to get a third authenticator, I need to get a separate privilege approval. How do we actually make that a lot more seamless to the end user, monitor that end user experience? And then from the top down, as we start implementing all of that automation from an incident response perspective, leveraging artificial intelligence, having standard APIs and API security across the environment, you're going to start seeing all of those threat scores go down. The risk scores goes down. You're able to do better target evaluation. You're better able to do triage priority. So being able to actually triage an incident instead of having a single user that calls in and has a problem with a system or has a security vulnerability. Once I have all of this data, that single user, instead of being a single incident, can become a problem. Now I can address 10 systems that have that same issue that we found because that user called in. It's being able to correlate, look for those indicators of compromise, look for that degraded performance of an application, whatever it might be, being able to do it in larger swaths so that your team can focus more on next steps. How do I actually improve my environment? How do I modernize? How do I look at the next technology? Because while we presented a lot of technologies in this lab today, our mission long-term is to continually build this lab, develop, bring in new technologies, evaluate technologies against each other, and really follow and understand what's the latest trend in IT and in IT security around zero trust, as well as operational sustainment. So with that, I will move over to the question and answer session. I really appreciate everybody's time. I'm going to go ahead and pull up the chat. It looks like Michael is the only one that really had a question for now. Michael, you had asked about the comparison of Illumio versus Guardicore, and I'm going to preface this with they each have their own benefits and their own drawbacks. The reality is we work with Illumio as well. I've worked with Illumio. I think Illumio is part of the ATARC Council or the ATARC Zero Trust Labs as well. They particularly hit on a lot of Windows systems. I have an entire paper. Actually, let me see if I have this up. And actually, is Michael, are you on?
Yes.
Yes, he
Okay.
showed up.
All right. Let me find this document here. So we have obviously a Guardicore competitive analysis and we have an Illumio competitive analysis, but to hit some of the high levels. So one, Guardicore has a little bit more extensive security value. So you can do Linux systems, you can do Windows systems all the way back to legacy and all the way up to new. It covers a lot more platforms and it allows a lot more labeling flexibility. Illumio restricts labeling a little bit more, and it doesn't just do network. It doesn't just do isolation. It does process. It does pattern behavior analysis on the system. So you're actually able to do more than just, the network segmentation. So when we look at what the coverage is, Illumio supports Windows 7 and 10. I think they've moved up to 11. It doesn't support anything working off of Azure AD today. I don't know if that's in the roadmap or not. It doesn't support any unmanaged Windows endpoints. So you're not going to be able to go out and discover any endpoints. And it doesn't support Linux endpoints. So Guardicore does support both of those. Again, it's if you're not going to be able to monitor or microsegment a Linux system, I mean, how often is Linux involved in an application? I haven't deployed an application, and I can't even name one where I deployed all Windows systems, right? From a labeling perspective, so Illumio has a 4-label limitation on all endpoints, and it doesn't allow you to use so many use cases. And I can send this out as part of our follow-up. Guardicore has a flexible labeling. It's agnostic of the server and endpoint agent. The labeling language used for endpoints is separated from the actual server. So we don't need to rely on what the server has from a labeling perspective. So for example, one, you use location in Illumio policy, it'll affect all asset types. It's not just going to affect that one exclusion. It's not possible. With Guardicore, you can define OS, Windows, and type endpoint to scope that policy, which you wouldn't be able to do in something like Illumio. From a management system, so Illumio is SaaS only. The one benefit that we've seen is that Guardicore can actually be deployed on-prem. Our environment is not SaaS, so what we have deployed within Guardicore is deployed within Azure AD on our own servers, and it scales as you add more. You can go out to the SaaS version, or you can stay on the on-prem version. It has both to build policies out of. The Illumio side only supports endpoint interfaces that are wired, wireless, and point-to-point VPN. Guardicore doesn't care whether it's connected via API or whatever it might be. The interface that it's actually connecting to, or the physical interface that's connecting, doesn't matter. So again, I can go through a number of these. I mean, from an endpoint labeling perspective, again, you use the application label. We're able to actually be flexible in that from that server endpoint perspective, actually putting them into individual groups. And, this is kind of just that high level, the function. So what can we do? Where is it at? And what are the differences between the two? There is a Gartner report as well as a few others. I also have a document that is on the Guardicore site, and we can send this out in the follow-up. But it just goes through the complete guide compared to Illumio. Agentless discovery. So we have agentless discovery in the environment, automatic application dependency mapping. So that dependency mapping, it's that behavior analysis. So it goes in and actually maps the dependencies of application when it's learning. So if it's calling a SQL server, if it's looking at Active Directory, or it needs an LDAP connection, it labels those all out so you can build the environments for a database environment, a middleware environment, a front end environment, et cetera, to build out that automatically within the map. We have tag synchronization and a list of filter options. So we can actually go out and automatically tag and orchestrate those tags within something like Splunk. We can create a comprehensive list of filter options within that environment. It supports legacy OSs. So we go all the way back. So when you think of like a industrial control network or those types of systems that are still running really old Windows systems, or even some of the federal government that's still Windows 2008, this goes back RHEL 5, CentOS 6, Windows 2003, as well as a number of other ones. And it also supports system where agents can't be deployed. So it can actually monitor systems that agents are not on to push and restrict those. So obviously this is the Guardicore focused pitch. Illumio does have their benefits, and Illumio is in the government. They've deployed their SaaS model, works really well, but where I see the true differentiators, if you're looking at an on-prem solution or you're looking to do something that is not necessarily able to be in the cloud yet, you can leverage the on-prem and still then go to the cloud later on. That help at all?
Chris, Michael also had another question about AppGate and Zscaler comparisons.
So Truax, I don't know how often you've gone into kind of the AppGate differential. I do know that AppGate has been coming up more and more. I have not done the Gartner analysis on AppGate today. I'm just going to be very honest with you. I'm not going to sit here and pretend to know something I don't know. But from a Zscaler perspective, it's been deployed, proven, tested in a number of environments across the federal government. I don't know how far AppGate has gotten. I know they've been tested in a couple of accounts. I haven't seen them present in many. Every vendor is going to have their solution that changes kind of what they do and how they integrate into a zero trust network access solution. Again, I don't necessarily know enough about AppGate's detailed functionality today to give you a true analysis. I mean, I know that they do. I know they have the ZTNA component. I know they have external consumer access. And again, with the same type of solution with Zscaler, Okta, even together, you get both of those capabilities. I mean, some of the customers that I showed you up there earlier on, a lot of that is the Zscaler Okta combination, whether it's CMS or HHS, that's what they're leveraging for that piece. But Michael, if you're interested, I'll take it as a note to mark down and get the Gartner, the modified Gartner report of that, as well as we'll do our own analysis. Yeah. So Michael said, AF prototype is operational in one, but it hasn't selected for wide deployment. Are you referring to the Air Force prototype for AppGate or for Zscaler? Okay. Yeah, so DISA has gone with Zscaler. There's other agencies out there. Treasury is moving over to Zscaler. There's some bake-offs in some other areas. AppGate was not selected as part of a recent bake-off with a customer. There's a couple other tools that were out there. But at the end of the day, again, it's kind of if it works, it works. If it doesn't, it doesn't. And, it's all coming down to that layer 10 decision of, what makes the most sense for your organization. If you guys haven't looked at Zscaler, I'm more than happy to help you look at that as well. But again, I'm sure you probably already did the analysis. You got it. Any other questions? All right. Well, we'll leave dead air. If anybody has any follow-up questions, you can always reach out to us. We will send out a follow-up with all of our information so that you can get a hold of our engineers or our account reps. You can hit us at raventech.com. If you want to see more on RavenVision, you can go out to raventech.com and click on the RavenVision link. And I will also collaborate and get the Guardicore Lumio comparisons and some of the other follow-up materials out to the attendees as requested. With that, I appreciate everybody's time. I know a 3-hour meeting looks scary. I'm glad that we got it done in a little bit under 2 hours. So if there's any other questions or any other follow-up, feel free to reach out, and we appreciate everybody's time today.